Hi there. Today we're going to talk about Lesson 41. Lesson 41 has to do with using formulas, and also as a part of using formulas it's going to talk about the distributive property. This isn't a difficult concept, but one that we need to discuss because it continues to build as long as you are in math. You will be using the distributive property quite a lot. So let's just start. We use formulas for many things, especially in geometry. One of the main things we use formulas in geometry for is to find area and perimeter. The area of a rectangle equals the product of its length and width. Once you've identified the length and width, you are able to find the area. Look at this example. We have a typical rectangle. The length and the width are labeled. And you're given the dimensions over here to the right. The length is 12 centimeters, the width is 7 centimeters. Now, we have a formula that we use for area of a rectangle. And the area formula is length times width. Okay? So it's a formula. It's a formula. So if we use the formula of length times width, we can find the area of this rectangle, and the area is 12 times 7, length times width, and it equals 84 centimeters squared. Be sure that you use squared for area. Volume is cubed, area is squared. The other thing that we use a formula quite often for in geometry is perimeter. Now, there are two formulas, not necessarily two separate, different formulas, but there are two ways that we can find perimeter using a formula. You can say 2 times the length, because remember perimeter here is distance around, so length plus width plus length plus width. 2 lengths plus 2 widths, or by using the distributive property down here, we can say 2 times the length plus the width. Now, does that make sense? Well, sure it does. Look back here in a minute. If I take this length plus this width, and then I take this length plus this width, I've taken 2 times the length plus the width. So that really shouldn't be too much of a surprise to you. Now we're going to talk a little bit about the distributive property. We're going to just continue with the length-width discussion here. Okay, we actually have the two sides, the two kinds of perimeter properties. One's on the left, one's on the right. 2 times length plus width, or 2 times the length plus 2 times the width. They are the same thing. You end up finding the very, very same thing because of the fact that you are going to distributive property. You're going to distribute this 2 over this length and this 2 over this width. Now that sounds confusing, so let's talk about it. There are some little rules in distributive property. You can only distribute multiplication over addition or subtraction. Only over addition or subtraction. You cannot distribute over division. Okay? And you are to distribute or spread the multiplication, spread means distribute to, over the terms that are being added or subtracted. So let's look at an example. Using length and width again. So we have 2 times the length plus the width. It's 2 times the quantity of length plus width. So notice my arrows. I have 2 times the length. I distributed the 2. And then I go ahead and distribute 2 times the width. And it looks like this. Ooh. 2 times the length plus 2 times the width. Doesn't look too bad. And then you go ahead and do it, and if you have the dimensions for length and width, you could find it. Now here's another example just using A, B, and C. You've got A times the quantity. This is red, the quantity. That means that the things inside are being added together, if it's possible. 2 times the quantity, B plus C. Well, in fact, because we cannot add B and C together, because you can't add bananas and cauliflower, then we have to use the distributive property, which we will do over here. We'll say apples times banana, or you could just say 2 times banana, or apples times cauliflower. because you can't add bananas and cauliflower together. Okay? And so you end up with apple bananas plus apple cauliflower. Now, in the real world, it's just going to be a number. This could be a number, and this could be a variable. And then you would end up with something a little bit different. Now, just to show you, it also works in subtraction. A times the quantity, B minus C, equals A times B minus A times C. And that's what it turns out to look like. Okay? Not too bad. Not too bad. Not too bad at all. Okay, let's do something that like maybe will make a little more sense to folks. Now you're gonna cringe when you see this, because every time we do these you go, oh, I hate these kind of problems. But all we're gonna do is just add a step to them. Okay? We can use this to the problems that we actually show steps on. And remember, this is simplifying, showing each step. So here we go. This is given. 2 times the quantity, 3 plus n plus 4. Remember, this is inside the parentheses. So this 2 is going to have to be distributed, yes. Okay? So we're going to distribute 2 times 3, which ends up to be that, and then 2 times n, which ends up to be that. Okay? Plus 4. And the reason, distributive property of multiplication. Next step is, well, it actually is kind of PEMDAS. We're actually just moving things around, so this is also going to be the commutative property. Okay? Next step, 6 plus 4 equals 2n. We have actually moved them. We add them together. 10 plus 2n. And that's, well, that one, that's really all further we can go, because we can't add n to anything unless we know what n is. So it's really an expression. Last one here, this one actually you might be able to do a little more with. We have 12 times the quantity, 3 plus r plus 4. So over here we do 12 times 3 plus 12 times r plus 4. And it looks like this. 12 times 3 plus 12 times r plus 4. Okay? Then we add the 12 times 3 with this 4. We get like terms together. 36 plus 4. Today is 36 plus 4. We move them so they're together. Okay? And that's that old commutative property and associative property. We end up with 40 plus 12r. Can't go any further because we don't know what r is. And these last two things I've showed you are really expressions. They're expressions because they have no equal sign. Had I put an equal sign in, then we would have started solving equations, which we're not quite there yet. Okay, thank you. I hope you had an awesome time listening to this, and we'll talk to you later.